Hi students, welcome to the next session of work energy problem. So yesterday we discussed about work energy theorem with the variable force and constant force and law of conservation of energy in case of freely falling body. And I told you to solve in case of vertically projected body. I think equation 1, 2, 3 you got I think half mu square. So for freely falling body you got mgh na, same like that you might have got of mv square. I hope all of you tried. So next concept, potential energy stored in a spring. So potential energy or energy stored in a spring. So how you will be getting it? Generally you will be coming to know whenever you are elongating the spring. Whenever you are elongating the spring, whenever you leave, after leaving this applied force, spring will come to the compression, original position. Whenever you are compressing the spring, so if you leave applied force, then spring is going to expand, isn't it? So whenever you are elongating, spring is going to pull that force against to that come. So if you are elongating means spring will pull upwards, isn't it? If you are elongating downwards. So if you are compressing like this, then spring will move in this direction. So quite opposite. So in that what is going to develop whenever you are elongating the spring? So let us assume this is the spring. For this spring you are attaching an object of mass m. This is the initial position. Now if you are elongating in this direction, if you have taken x-axis, y-axis, so this is positive x-axis, this is negative x-axis, this is positive y-axis, negative y-axis, isn't it? If we are elongating this one like this, what spring will do? Spring will apply force in this direction. Means spring is pulling this object in this direction. You are pulling this object in this direction. Because of this elongation, what is developed in the spring means restoring force is developed. That one we will say restoring force. This force developed within the spring, therefore we are calling it as restoring force. So why we are saying restoring means, again if you are elongating this one, again spring will try to keep the object in the same position, means it is gaining its original position, restoring its original position. Therefore we are saying restoring force. Restoring force will develop within the spring. So therefore whenever we are elongating the spring, spring is coming to the original position means in that restoring force will develop. How the restoring force will develop means quite opposite to elongation. So this is nothing but either spring force or restoring force we will say. So spring force is in negative x-axis direction. Elongation is in positive x-axis direction. Isn't it? So same object. Now object is here, this elongation is x. So this is positive x. Spring force will be, both are quite opposite. So up to where you can elongate like this, up to where this restoring force will develop. If you are elongating spring, more force if you apply means, more elongation if you apply means, it won't come again upward, means restoring force will not develop. So for that you will be having limit. What is that limit means? Proportionality limit they will say. So this one according to said by Hooke's law they will say. Hooke's law means within the proportionality limit force is directly proportional to elongation they will say. So up to some limit only, so it is going to develop restoring force. After some limit if you elongate the spring means again spring won't come backwards, means you crossed that limit, isn't it? So that is nothing but Hooke's law. According to Hooke's law, this force is always directly proportional to elongation, and both are quite opposite. Quite opposite means if you are elongating in positive x-axis direction, restoring force will develop in negative x-axis direction. So this is about elongation I said. Now I will say about compression, but both are quite opposite. So if you want to remove this proportionality, we will write one constant. The constant we will say K. So what is K here means spring constant. Spring constant or force constant. Then K is equal to F by X. Restoring spring constant or force constant definition. Restoring force per unit elongation. Restoring force per elongation they will say. Sometimes they will ask dimension formula on units. Units means, what are the units? Force units, Newton. Elongation units, meter. Elongation means displacement, Newton per meter. Dimension formula. Whenever unit dimension formula definition name, you will get obviously dimension formula. What is the dimension formula for K? Force, elongation distance, length, that is L. Therefore, m t power minus 2. This is the force constant or spring constant units and dimensional formula. So F is equal to minus Ks. So the restoring force developed within the spring, Fs. So Fs refers spring here. So restoring force developed in the spring. So F is equal to minus Ks. This minus indicates both force and elongation are in opposite direction. But whenever we are defining spring constant, that negative we are not taking here. We have to remember this. Okay, whenever we are going for a definition, restoring force per unit elongation. Restoring force means in the name only it is there. Always it will be opposite to x. Therefore, while defining, we will say restoring force. While writing the equation, we will write with minus sign. F is equal to minus k. This F is here restoring force developed within the spring. So here I have shown for you elongation. Now we will see compression. Compression means we press this object inside. So if you press like this, if you leave external force, again it is going into the original position. At the time, how the direction of the restoring force we will see. So this is nothing but compression. Same object of mass. Now you compress it like this. In this direction. Negative x-axis means this is in this direction. At the time, this spring is going to pull this object in this direction, in opposite direction. That is nothing but in this. Again, restoring force developed within the spring is quite opposite to elongation. So minus kx. Therefore, finally, Fs is equal to minus kx. What is this Fs? Restoring force developed within the spring. So this is positive displacement, this is negative displacement. If you have taken, this is origin at x equal to 0. So whenever we are applying, so positive elongation, positive x-axis, force is developing within along negative x-axis. So directions are always opposite. Now whenever we are elongating, so spring is doing some amount of force. Like that, we are applying some amount of force on the block. How much how much force spring is restoring, same amount of force we are applying. Otherwise, how much force we are applying on this object to pull this towards like this, same amount of force is developing within the spring. Means applied force and force developed within the spring always same. Now elongation is there, spring is applying some force, we are applying some external force. So therefore, how much force we are applying means same amount of force, but direction is different. Isn't it? Our applied force. This is applied force. Our applied force is in this direction. Therefore, elongation also in this direction. Then what is theta? 0. So our applied force is like this, elongation is like this, but restoring force will be opposite. Then what is theta? 180. Therefore, work done by applied force is always positive because angle is 0. Work done by restoring force, work done by spring force, work done by restoring force or work done by spring force is always negative. Why? Because both force and displacements are negative. First one I am saying because we are going to get negative there. So whenever x is greater than 0, less than 0, how it is going to be varied? They gave graph also 5. Now equation we are given. So this is explanation for what we are going to discuss, how the energy is stored in the spring. So this is restoring force equation according to Hooke's law. We got this statement and spring constant, definition, dimension, formula, units we give, isn't it? And when it is positive, when it is negative, work done we give. Now we are going to derive that energy stored in the spring. So for any energy I told you, either potential energy or kinetic energy. So which equation we have to take? Work done. Work done equation we have to take. Now here, so work done equation W is equal to force into displacement. Correct? Now what is the force equation we got? Force equation is F, yes, restoring force. So Fs is equal to minus Kx. So this x is varying from here, 0 to some maximum value. We are bringing this one here from this value. This one we are taking it as xm up to maximum value. In that, x is varying from 0 to xm. 0 to xm. Xm means maximum elongation. So therefore, whenever x is varying from 0 to xm, this x is varying. Therefore, this work done also will be varying. So for small amount of dx means anywhere we will take some amount of dx, small dx. For small elongation, what is the work done? For small elongation dx, what is the work done means W is equal to F into dx. Therefore, dW we have to take. Why we wrote dW here? Because we wrote here for small displacement or for small elongation, work done is how much means dW. Force we won't change. Force is how much? Kx only. Okay. So we want work done. Whenever we want work done, we should do integration. Integration on both sides. So integral dW is equal to integral f dx. This dx is varying from 0 to xm. Xm means the maximum elongation. So integral dx, what is the formula? Yesterday we gave integral dx is nothing but x. Therefore integral dw is w. F value, that is force developed within the spring. F is how much? Minus kx dx. This is 0 to xm. So minus k is constant. X dx. Integral x dx. What is the formula? Integral x power n dx. X power n plus 1 by n plus 1 minus k into x power 1 plus 1 by 1 plus 1 0 to xm. So first we have to substitute upper limit. Xm square by 2 minus 0 square by 2. Then we got finally minus k xm square by 2. So this one only we are saying it as potential energy. So U is equal to minus of k x square or xm square. Xm means maximum value of the elongation. Now you got negative, minus you got, isn't it? So that is energy stored within the spring. So work done by, and this equation we got work done by spring force. Work done by spring force minus of kxm square by minus of kxm square means work done by applied force you will get plus k 1 by 2 x m square. Just you will get positive sign. So work done by spring force means negative you have to take. Work done by applied force means you have to take positive. Okay. So this is the energy stored in the spring derivation. This one they will ask for 3 marks question. Very very important question. Next, how we are going to draw the graph between force and elongation or displacement derivation. So we said spring force and elongation always both are in opposite direction. Whenever it is 0, elongation is 0, force is also 0. Whenever elongation is increasing, restoring force also will increase, but in opposite direction. Direction is going to be opposite. Therefore, whenever we are drawing the graph, spring force on y-axis, elongation on x-axis. So if we are elongating in positive direction, force is increasing in negative direction, opposite direction. Therefore, it is starting from 0, but it is increasing. So you have to draw like this. So x is positive, then f is negative. Negative means opposite direction. Whenever x is negative, force is opposite. Therefore, you will get like this. So Fs is equal to minus Kx. So this is the graph. If you have taken area, this area gives minus half Kx m square. Means area under force and elongation graph gives work done or energy stored within the spring. So if x is greater than 0, Fs is less than 0, isn't it? If x is less than 0, Fs is greater than 0. So this is nothing but energy stored. And whenever it is at origin, so its energy is going to be 0. Whenever it is at maximum amplitude, there is nothing but maximum elongation, potential energy is going to become maximum. Whenever it is minimum, so it is minimum. So maximum only, but it is going in negative direction. If you have drawn graph means for energy and variation, at origin it will be 0. So U is equal to minus of Kx m. Therefore it is parabolic equation. Therefore you will be getting graph like this. So this is positive xm. So this is negative xm. This is origin 0. So this is nothing but energy. So energy and elongation graph you will be getting. So it's in more detail you will discuss in simple harmonic motion. But whenever you left this one, so this will also try to oscillate. So that is motion we are going to call it as simple harmonic motion. Whenever we are taking initial position to final position. Initial position to final position means same result. Here we have taken from initial position is 0, final position xm. So somewhere we are taking initial position to final position. At that time you will be getting the equation like this. dw is equal to Fs into dx. dw is equal to minus Kx dx. Now integration on both sides. Integral dw is equal to integral xi to xf. This equation we derived 0 to x. Initial position to final position. Minus Kx dx. Both are same only. So minus k into xi to xf x dx. Integral x dx already we gave. Actually this is not required. Just I am giving whenever competitive it is coming, we will be helpful. So minus k by 2 xf square minus x I square. If both are same means you will be getting resultant work done is 0. So when resultant work done is 0 by a force, then that force we are calling it as conservative force. Conservative force. So next we are going to discuss about the conservative and non-conservative force. So force is said to be conservative, what is going to happen? If force is said to be non-conservative, what is going to happen? And what are the examples? Very, very important for 2 marks. Define conservative, non-conservative force, or give the example for conservative and non-conservative force they will ask. Now we will see that. Okay. So next, conservative and non-conservative forces. So conservative and non-conservative forces. So first define conservative force they will ask, or give any example for conservative force. A force is said to be conservative means the resultant work done in a closed path is going to be 0 and it does not depend on the path followed by the object. So this is definition. Just after giving example and explanation you can only get understood. It does not depend on the path followed by the object, and in a closed path or resultant work done is going to become 0. So then force is said to be conservative. So take one example. I am taking an object at position A. So I am bringing this object up to height H. Next I am bringing this object up to C through a displacement S. This is D. Next I am bringing finally through same height, but it is downwards, it is upwards. Towards like this, displacement like this. So now I have taken an object, I have started initially from A to B, B to C, C to D, D to A. This is nothing but one closed path. So now what is the resultant work done? Resultant work done means here total 4 times weight. Therefore 4 work done we have written. Resultant work done. W is equal to, so from A to B, W AB plus W work done from B to C, work done from C to D, so work done from D to A. So AB, BC, CD, DA. So total complete path. Now we are calculating work done by gravitational force. So work done by gravitational force in this total paths we are going to calculate. First we are taking work done from A to B. So we are bringing in upward direction. Gravitational force will be acting. How it will be acting? Gravitational force F is equal to mg. Mg is acting downwards. Displacement is in upward direction. Both are in opposite direction. Then work done will be negative or positive? Negative. Otherwise directly write formula. F S cos theta. F value gravitational force mg. Yes, displacement h. What is angle? Cos 180. Because gravitational force will be downwards, displacement will be upwards. Therefore angle is 180. Cos 180 value mgh. Work done to bring the object from A to B is nothing but minus mgh. Next, work done to bring object from B to C. Gravitational force will act downwards. B to C. Displacement is in this direction. Now what is the angle? Angle is how much? 90 degrees. Then directly we can write Fs cos 90. Cos 90 means 0. So work done to bring the object from B to C is going to become 0. Work done by the gravitational force. Next we are bringing object from C to D. Work done to bring the object from C to D is equal to Fs cos theta. Now gravitational force is acting downwards. Displacement also downwards. Both are acting downwards means theta value how much? 0. Gravitational force mg. S is nothing but how much displacement we want? H cos 0. Cos 0 value 1. Therefore mgh. This is the work done from C to D. Next work done from D to A. So gravitational force is acting downwards. What is the angle? Theta 90. So D to A. So Fs cos 90. That is nothing but 0. Now what is the total work done you can see. So work done. W is equal to WAB. How much we got? Minus mgh. Next, WBC. From B to C how much? 0. Next, C to D how much? Plus mgh plus 0. Therefore, resultant work done through ABCD is going to become 0. So total work done in a closed path is going to become 0. So now because of which force this work done is 0? Because of gravitational force. Therefore gravitational force. So gravitational force is which force? Conservative force. Like that, electric force and the spring force. Previously we discussed about spring force. Spring force will be also coming under conservative force, and the electric force, electrostatic force will say. Electric force means where you will be getting means. So in TV screen, after using TV, if you go for near the TV screen, so hair of your hand will attract, or hair of your body is going to attract towards the TV screen, isn't it? So there, electrical force is there between hand and your TV screen. Like that sometimes in summer season, if you are sitting on the plastic chair, you may feel this hair is attracted towards the plastic chair. At the time, electric force is there. In your school days, they may say that experiment. On comb and dry hair, if you rub means pieces of paper is going to attract. So between comb and the pieces of paper, which force is there? Electric force. All these forces will be coming under conservative forces. Okay, this is the example for conservative force, and it does not depend on the path followed by the object. In the, whatever closure path you are taking from A to B, B to D, D to A, you will be getting 0. So A to B, B to A, you will be getting 0. So it does not depend on the path followed by the object. So force is said to be conservative force, means resultant work done in a closed path should be 0, and work done, and it does not depend on the path followed by the object. Work done does not depend on the path followed by the object. Then the force is said to be conservative force. Examples: gravitational force, spring force, electrical force. Now, non-conservative force. Non-conservative force means reverse. So, resultant work done will not be 0, and it depends on the path followed by the object. So, now what is the example? Example means here. If you have taken a toy car or any object, you can take. So, this toy car is moving like this. So, after some time, it is here like this. It covers the displacement case. After some time, it is going to be stopped. Stopped means because of which force? Because of frictional force. Displacement is in this direction. Frictional force is in opposite direction. Now, what is the angle? Angle between frictional force and displacement is 180. So, from A to B. So, work done from A to B is equal to Fs cos theta. F is frictional force, S is displacement, cos 180 minus Fs. Now, car came from B to A. So, close the path we are taking. B to A whenever it came. So, whenever B to A, displacement is in this direction, the frictional force is opposite direction. Isn't it? Both are going to be reverse direction. Then again, what is angle? 180. And W B to A. What do you get? So Fs cos theta. Fs cos 180. So minus Fs. Then total work done. WAB plus WBA minus Fs minus Fs minus 2Fs. That is not equal to 0. So therefore, in a closed path, work done by frictional force. Which force here? Work done by frictional force is not equal to 0. Therefore, frictional force will be coming under which force? Non-conservative force. This is the example for non-conservative force. These are the examples for conservative force. So small and simple logic if you follow, you can write. This is important for 2 marks they will ask. Any examples they will ask or definition they will ask. So conservative means resultant work done will be 0 in a closed path, and it does not depend on the path followed by the object. Then force is said to be non-conservative means resultant work done is not equal to 0, and it depends on the path followed by the object. Okay, this is about conservative and non-conservative. Next we will see power. So till now we discussed about work done and energy. So both will be same only we discussed. But units, work done, energy, units also will be same only. Now we are going to discuss about power. So power also depends on work done only. So I will give example for you. You will only say power. Power definition. Without knowing definition, who is having more power, you will only say. So I have given for you 50 chairs to bring from one place to another place. So one person did that work within 10 minutes. One person did same work within 1 hour. One person did same work within 6 hours. Now who is having more power? All of them, they have done same work. So they brought 50 chairs from one place to another place. But one person did within 10 minutes, one person did within 1 hour, another person did within 6 hours. Now who is having more power? Who is having more power means who did the work within less time. So the rate of work done. the rate of work done is called. So work done per unit time. So power is equal to work by time or rate of doing work. So dW by dt or work done by time. So this is the definition of power. Now what are the units? Whenever definition came, units will come. Whenever units came, dimension formula will come. So already we discussed about all this, but generally again we are giving, because each and every lesson, each and every definition will be having units and dimensions. So power, units. Work done units we came to know joules. Time units we came to know seconds. So joule per second. So always we won't write joule per second. Therefore we will write watts. Simply we will say W. James Watts. So scientist name this is. Therefore you can write whenever you are using capital W. Capital W refers watts. Watts is the unit of power. Now what is the dimension formula for watt? Watts. So watts means directly we can't write. What is the dimension formula for power? Therefore power definition is work by time. So therefore dimension formula for power is equal to work by time. Work means mL square t power minus 2 by t. So mL square t power minus 3. If you forgot work done dimension formula means again you have to write. Work done is force into displacement. Already we gave how to remember, how to write the dimension formula. You can't by heart, you have to remember logically. mL square t power minus 3 is the dimension formula for power. And units joule per second or watts. Conversions will be there for this. So you came to know still now. So they will use power of the engine. So they will do within horsepower. Horse is having more power. So 1 horsepower is equal to 746 watts. 1 horsepower is equal to 746 watts. So sometimes they will give in horsepower. To convert that one into watts, we have to multiply with 746. And another unit, I told you whenever energy units came, joule is one of the unit for energy, electron volt is one of the unit for energy, another one I gave calorie. Did you remember? Joule and EV, electron volt and calorie. So 1 EV is equal to 1.6 into 10 power minus 19 joules. Calorie 4.18 or 4.2 joules. Now another unit of energy. I am not saying about power, I am saying about energy. Another unit of energy. So by using this power equation. Therefore I didn't give at the time. Now we got power definition. Therefore I am going to give another unit of energy with the help of power. Power is nothing but work by time. Just I am giving energy units. Power units watts. Work done units joules. Now joule is equal to watt second. So joule is nothing but watt second. So this one they will convert into hours. Hours how they will convert. So 1 kilowatt hour or kilowatt hour or watt hour. 1 watt hour. Watt hour is the unit of which one? Which physical quantity? Watt second is equal to joule means watt hour also equal to joule. Just second we have written as hour here. Now we will see. 1 watt hour is nothing but 1 watt. Hour means how many seconds? 60 seconds. 60 seconds, huh? 60 minutes. So 1 hour is equal to 60 minutes. So 1 watt 60 into 60 seconds. 3600 watt second. Now watt second is nothing but joule. Therefore 1 watt hour is equal to 3600 joules. So joule is the unit of energy. So watt hour is also unit of energy. Whenever watt is there, you may think this is power unit. You should not think like that. Watt hour is the unit of energy. 1 watt hour is equal to 3600 joules. Next they will ask 1 kilowatt hour. So 1 kilowatt hour. 1 kilowatt hour means 1 kilo means how much? 10 cube watt hour. So watt 3600 seconds. Again, watt second is nothing but energy. Therefore, 1 kilowatt hour is equal to 3600 into 10 cube into watt second. So this is another 2 zeros are there. Therefore, 36 into 10 square into 10 cube. This watt second can be written as joule. 36 into 10 power 5 joules. 1 kilowatt hour. This one only they will write in another way. They will divide and multiply with 10. So 3.6 into 10 power 6 joules. 1 kilowatt hour. Just to remember 3.6 10 power 6. 0.6 10 power 6. They will ask him one more question. 1 kilowatt hour is equal to how many joules? 3.6 into 10 power 6 joules. So kilowatt hour is the unit of which one? Unit of energy. So we will get confused whenever they get what is there means you will think that is a unit of power. That is kilowatt hour. Kilowatt hour or watt hour. Unit is the this is the unit of energy. You have to remember. And another logical question in this. So what is the largest unit and smallest unit of energy they will ask? What is the largest and smallest unit of energy? So what is the largest and smallest unit of energy means largest, see here, 10 power 6 positive value. 10 power 1 means 10, 10 square means 100, 10 cube means 1000, 10 power 5 means 10,000. 10 power 4 means 10,000. So like that this number is going to increase. Right? The 10 power 6 means this value is more. So therefore largest unit is kilowatt hour. What is the smallest unit? Smallest means minus 6 will be there. This is minus 19. 10 power minus 1, 0.1. 10 power minus 2, 0.01. 10 power minus 3, 0.001. That is 10 power minus 19, 0.18 zeros, 19 zeros you have to keep. Therefore, this is the smallest value. Now, largest unit is what? Largest unit is kilowatt hour. Smallest unit is electron volt. In one more question they will ask. So, what is the largest unit and smallest unit of energy they will ask? Smallest unit is electron volt. Largest unit is kilowatt hour. And 1 kilowatt hour equal to how many joules also they will ask. So, at the time, so you can take this value. You have to remember. Next time. Power in terms of velocity. How you will be getting is, we came to know power definition. Power is equal to so work done by time. So now what is work done equation? Work done equation F bar dot S bar. You can derive this one in two ways. dW by dt. So whenever dW is there, how you write? F into dx or F bar dot dx bar by because whenever dW is there, what is work done? dW is equal to F into dx. So both are in same direction means F dx. So angle if you want to write means F bar dot dx bar. So now displacement by time. Displacement by time gives what it is displacement by time? Velocity. So F bar dot S. Here dx by dt. Dx by dt. This is also velocity. Now power P is equal to F bar dot V bar. Now power is the another example of scalar product. Work done is one of the example. F bar dot S bar. Work done is example for scalar product. Now power is also example for scalar product. F bar dot V bar. Because V is velocity vector, force is vector. Therefore dot product is going to give scalar. Now power is nothing but scalar quantity. So whenever they give force and velocity, you have to use power equation by the F bar dot V bar. Whenever they give work done in time, you have to use this equation. So work done will be stored in so many ways, either potential energy or kinetic energy. So depending on situation, sometimes you have to write here potential energy, sometimes you have to write here kinetic energy. So if we are going for staircase, we are going from bottom step to final step. So n steps you went, otherwise 10 steps. After reaching your last step, what is the power? Because same staircase, all the people cannot go in the same time. One person can go within 5 minutes, one person can go in within 10 minutes. Depending on the time variation, who will be having more power, we will say by using this equation. So this is about power units and largest unit, smallest unit of energy, and power equation in terms of velocity, F bar dot V bar. Okay. So next we will be having, after power, we will be having the concept of collisions in this work energy power system. Collision. So generally we will say two bodies got collide, accident we will say. So for that, definition will be there. The strong interaction between two objects, or the interaction between two objects. So that is called collision we will say. But whenever collision is going to happen, so some physical quantities are going to exchange or transfer. Already we will be coming down. So if you are playing carom board between the coins, collision is going to happen. So whenever the collision is going to happen, so if you are hitting the striker, so striker is hitting a coin. So collision between striker and coin. So billiard ball games, white ball with red ball, yellow ball, like that. So those also we are calling it as collision. So whenever collision is going to happen, so its striker momentum is going for coin. So how we will say this one, momentum. What is meant by momentum? Already you came to know, product of mass and velocity. And whenever it is getting momentum, it is gaining energy. So energy is also, which energy? Kinetic energy is going to be transferred from one object to another object. Okay. So two bodies got accident. Accident also we are calling it as collision. So its momentum is going for another object. One kinetic energy is going for another object. So depending on the momentum and kinetic energy transferring, so we are saying there are two types of collision. One is elastic collision. Another one is inelastic collision. Elastic collision and inelastic collision. So what is meant by momentum? Generally, momentum is nothing but product of mass and velocity. So if the collision is said to be elastic, when the collision is said to be elastic means if both momentum and kinetic energy conserved. So the collision is said to be elastic collision if momentum and kinetic energy are conserved during the collision. Next up, inelastic collision. Inelastic means only momentum conserved but not kinetic energy. So only momentum conserved but kinetic energy will not conserve in inelastic collision. Then that type of collision we are calling it as inelastic collision. So where it is going to happen? So elastic collision, fundamental particles, electrons, protons, all these we will be getting elastic collision. So inelastic. Inelastic means after getting embedded, both are moving with same velocity. If your bullet is firing from one place and it is going to place in wooden block, then that collision we are calling it as inelastic collision. Only in the momentum. Now see here, in both the collisions, momentum is conserved, but kinetic energy conserved only in elastic collision. So kinetic energy is not conserved in inelastic collision. So and again, in elastic collision, I am saying in elastic collision, that is different. In inelastic collision is different. Okay. So in elastic collision, momentum, kinetic energy conserved. Again, this type of collision will be happening in two ways: one dimensional, two dimensional. So especially we are going to discuss about one dimensional collision. For the collision, how many bodies required means minimum two objects required. Okay. So that one we are going to discuss tomorrow about elastic, inelastic collision. Then what is their velocities after the collision, and what are those velocities before the collision, and what are the physical quantities. So these are momentum and kinetic energy is going to be exchanged or changing. So before going to the topic tomorrow, so today we will have small discussion on kinetic energy and momentum relation. So already we came to know kinetic energy. So this is relation between kinetic energy and momentum. So what is kinetic energy equation we came to know? Ke is equal to half mv square. What is momentum equation we came to know? P is equal to mv. Now we want relation between kinetic energy and momentum. Then substitute this V in this equation. V is equal to P by, in this equation we can substitute. So then now m P square by m square. 1m will be cancelled. Then P square by 2m. So kinetic energy K is equal to P square by 2m. So this energy relation, kinetic energy momentum relation, you will be getting say up to your second year. So very important relation you have to remember. K is equal to P square by 2m. So if momentum is constant, then mass is inversely proportional to kinetic energy. If momentum is constant, mass is inversely proportional to kinetic energy. Sometimes velocity is constant everywhere. At the time, mass is directly proportional to kinetic energy. So how they will ask question means both car and lorry are moving with same momentum. Then they are going to apply brakes at same time. Then which one will come to rest first? Which one is going to come rest first means which is having less energy, it will be coming to rest first. We will see that one according to equation. So if you have taken a car, if you have taken a lorry, so mass of the car is mc, mass of the lorry is ml. So momentum of car is pc, momentum of lorry is pl. They gave both are moving with same momentum. So both are moving with same momentum means so momentum is constant. Then if you have taken kinetic energy of car is equal to pc square by 2m. Kinetic energy of the lorry pl square by 2ml. So momentum is constant means kinetic energy is depending on mass. Kc is inversely proportional to mc. Kl is inversely proportional to ml. So which mass is more? Mass of lorry is more. Ml is more means Kl is less. Ml is more means kinetic energy of lorry will be less. Mass of the car is less and kinetic energy of car is more. Kinetic energy is less means it will be coming to rest first compared to car. So first lorry will come to rest first, later car will be coming to rest. So which is covering less distance, more distance they will ask. Which is covering less distance, lorry will cover less distance or car will cover less distance. So now which is having more kinetic energy, car is having more kinetic. Then what is the relation between work done and kinetic energy? Already we came to know. So what is the relation between work done and kinetic energy? W is equal to delta K of mv square minus of mv square. Initial velocity. Whenever we are applying brakes, it will be having some initial velocity, but final velocity is 0. Therefore, work done is equal to half m u square. So this one only work done is equal to kinetic energy. General work done equation F into S. So both apply same force on car and lorry. Therefore, kinetic energy is directly proportional to displacement. Therefore, which is having more energy? Car is having more energy, lorry is having less energy. So car is having more energy. Therefore, displacement of car is more compared to displacement of lorry. So they will ask this type of questions. You have to remember carefully by using formula you can write. So this one is applicable whenever both car and lorry are moving with same momentum. Okay. Next we will see. So next if both are moving with same velocity. This one we discussed both are moving with same momentum. At the time, so lorry is having less energy, therefore it is going to cover less distance. Car is having more energy, therefore it is covering more distance. This is only if momentum is same. Sometimes they will give velocity of car is equal to velocity of lorry. Both are moving with same velocity, then they apply suddenly brakes. At that time it will come to rest first, which will come to rest. At that time kinetic energy and velocity relation you should take. You should not take momentum relation. So Kc is equal to half MBC square. KL is equal to half MVL square. So VC is equal to VL. Then MC, ML. So ML is greater than MC. So KC is directly proportional to MC. KL is directly proportional to ML. ML is more, KL is more. MC is less, KC is less. Therefore, so which energy is more? Lorry kinetic energy more. Lorry kinetic energy more means displacement of lorry will be more, displacement of car will be less. When both are moving with same velocity. If both are moving with same momentum, reverse. Both are moving with same velocity, it is going to be awkward. So this type of logical questions you have to remember. So whenever you are using that, if you know how to use the formulas, then you can get this type of simple logical questions. You will get very easy. So next, our topic is this one: elastic, inelastic. Inelastic collision will be having less. Only elastic collision we will discuss. One-dimensional elastic collision. Okay. Tomorrow we'll see.